Okay, so it did say mentally evaluate the following logarithm expressions. Place them in order from least to greatest. Okay, so if I were sitting here and I was like, I don't even know what these numbers are, I could go into my calculator, and my people who are online, I could go into my calculator, and I could say log of 10. And that tells me that it's 1, right? Okay, fun fact, if your base is the same as this number, it's always going to be equal to 1. Okay, so let's do log of 1. What does that give us? 0, right? We've got log of 0.1. What do you think log of 100 is going to give me? If log of 1 is 0, log of 10 is 1, what do you think log of 100 is going to be? What do I have to raise 10 to get 100? 2, right? What do I have to raise 10 to get 1 over 100? Negative 2. What do I have to raise 10 to get 10,000? 1, 2, 3, 4. Right, so if we put these in least to greatest, we're going to have this one go first. So E, I'm sorry, yeah, E, and then we would have C, and then we would have B, A, F, and then D. Okay? So you should be able to evaluate these. Notice how I did the first one, and I said, okay, well this is just saying, all right, 10 to what power gives you 10? Okay, and that would be my number over here. So yesterday we talked about how if we had log of base of the solution equals the exponent, then we can turn this into an exponential function by taking the base, raising it to an exponent, and setting it equal to the solution. So base, raising it to the exponent, equal to the solution. Okay, so this is what we talked about yesterday. So we're going to continue on with that into today's stuff. But we're going to work out of base 2. So yesterday we worked out of base 10. Today we're going to work out of base 2. Okay, so it says, using the table to find the exact or approximate value of each expression, then explain to a partner what each expression and its approximated value means. So we're going to actually do this all together. Again, we're working out of that base 2. So notice how yesterday we had log of base 10 of x, and today we have log of base 2 of x. Okay? So, log of base 2 of 2. So, how do I read the table? How do I read the table? Do I go to this 2, or do I go to this 2? Okay? When I'm looking at this number is x. Okay, so when I'm looking at this table, and I'm looking for when x is 2, what's y? So when x is 2, what's y? 1. Okay, and just like what I said at the beginning, if your base is the same as your solution right here, then it's always going to be equal to 1. Okay? So what about the next one? It says 32. Log of base 2 of 32. So we're going over here. We look at 32. What is it? 5. Okay? And this seems right because we know that 2 to the 5th power equals 32. Remember, 2 to the 5th power is the same thing as saying 2 times 2 times 2 times 2 times 2. But nobody wants to say that many 2's, so we say 2 to the 5th power. Go ahead and take a moment and try to find C and D. Try to find C and D. So looking at C, it says log of base 2 of 15. So I'm going to look when x is 15, what's my y? 3.9069. All right, on D, it says log of base 2 of 40. X is 40. What's my Y? 5.3219. Okay? Now it says solve each equation, write the solution as a logarithmic expression. So let's start with A. It says 2 to the Y, ooh, that's a weird Y, equals 5. So remember, we're going to write it as a logarithmic expression. So we're always going to start with our base, go to the outside, and finish at our exponent. So log of base 2 of 5, log of base 2 of 5 equals Y. And so now this is the same thing as what we were doing right here. So we're going to look at when X is 5, what is Y? Y is 2.3219. So go ahead and take a second and try to do B and C. Try to do B. Okay. So on part B, we've got 2 to the Y equals 70. So again, we start at our base, we go over to our outside, finish at our exponent. So log of base 2 of 70 equals Y. Okay, but 70 isn't listed here. So there's a couple different ways we can actually do this one. We can do something called the change of base formula. I'm going to go ahead and show you how to do that. So change of base. And I would write this down on my paper. So change of base. What's going to happen is you're going to, in your calculator, type log of your solution divided by the log of your base. So for our problem, what that's going to look like is we're going to take log of 70 and divide it by log of 2. And that's going to give us our Y. So when I go into my calculator and I type, and I've got to make sure that I use my parentheses. So log of 70, close parentheses, divided by log of 2. That's going to give me 6.1292. 6. So Y equals 6.1292. Okay. And that pretty much lines up with what we would see on the chart. Because as we can see, we've got 40 is 5, right? Roughly. Or 32 is 5 right here. Okay. The reason why we do a change of base is because we're working out of base 2 right now. But with change of base formula, we change it to a base of 10, which is a number system that we like to work in. That's the number system that our calculator likes to work in. Okay? If you type directly into the calculator and you do log 2 of 70, it doesn't give you the same answer. This is really like taking the log of 140. Okay, so it doesn't work. Okay, so looking at the next one, we've got 2 to the Y equals 999. So we know that that's going to switch to log of base 2 of 999. Okay, again, we're going to have to use that change of base formula in order to solve this, which is going to be log of 999 divided by log of 2. So I'm going to go into my calculator and I'm going to type log of 999 divided by log of 2. And that's going to give me 9.9643. So 9.9643. Okay. So from exponential to log form, we're going to start at our base, go to the outside, finish at our exponent. So log of base 10 of 1 equals 0. For log of base 5 of 1 equals 0, we're going to do 5 to the 0 power equals 1. For this one, we're going to do log of base 10 of 1/10 equals -1. And for this one, we got log of base 9 of 3 equals 1/2. For this one, we're going to have 2 to the -3rd equals 1/8. Notice how in that circle, I start with my base and then I go from there. That's how you always write it out, in that order. Okay? Then I've got log of base 2 of 15 equals y. 5 to the y power equals 40. And log of b of x equals y. Okay? Okay. So, over here, we've got, to what exponent do we raise 4 to get 64? And the log of base 4 of 64 equals question mark. Okay? Again, if we were going to solve this, we would put it into change of base form. On this one, we would get log of base 2 of 128. If we want to put this in exponential, we're going to go from 2 to question mark equals 128. And again, if we wanted to solve this, we would go log of 128 divided by log of 2. Okay?